Hello, hello, hello. Welcome to Ratios and Rates. This is Stage 4, Year 2, Maths content. We're up to lesson number 5, but I want us to start off with a bit of review because we learned a lot in those first few lessons and we definitely need to review before we start doing some real world stuff with drawings, with maps, scale drawings. So first, I'm just going to make myself real small today, right up in the corner. I've made the calculator really small as well because there's a lot on this page. So what we have here, make that full screen. On the left are some questions I want you to do, and these aren't in your booklet, so you have to write this down in a book. Just writing down answers. We've got some warm-up questions, 1, 2, and 3, and then there's 2 more, 4 and 5, which are a little bit harder, and it's all the stuff from the previous lessons. So the review questions, number 1, the ratio of chickens to sheep is 3 to 1. What does that even mean? Then you have number 2. Are these pairs of ratios equivalent? Girls to boys 5 to 4, boys to girls 4 to 5. Are those the same? And then we have length to width is 1 to 2, length to width 4 to 8. Number C, people to piranhas 2 to 10. And then people to piranhas 3 to 11. Are those ratios the same? So you had 2 to 10, then you add 1 extra person, 1 extra piranha. Is the ratio from piranha to person still the same? And then number 3, simplifying some ratios, just numbers there. I want you to simplify them. Now, if you've forgotten, which is totally fine, I've got on the right the cheat notes, right? It tells you how to do everything. So like the first one, you don't know what to do on the left, just look across to the right. Same with number 2, same with number 3. So it's all there to help you out. So I'm going to pause now, and I want you to have a go. Questions 1, 2, and 3. When we unpause, I'm going to give you answers before we move on to 4 and 5. So pausing in 3, 2, 1. All right, here are your answers. So ratio of chickens to sheep, 3 to 1. It means there are 3 chickens for each sheep. 3 chickens for each 1 sheep. The order matters. 3 is the chickens, sheep is the 1. Number 2A, are those girls to boys ratios equal to each other, equivalent? Yep. The order's been swapped. In both cases, girls is 5, boys is 4. Those are equal. So B, are those equal as well? Yeah. If you got 1 centimeter length and 2 centimeter width, and you got length 4, width 8, those are the same ratios because each time the width is twice as big as the length. In both cases, the width is twice as big as the length. That's what matters here. And we like to write things simply. So that's why we would prefer to simplify that 4 to 8 down to 1 to 2. The piranhas question. Are the ratios between piranhas and people equal? No, definitely not. The first one, it's a ratio of 2 to 10. It's 1 to 5. That's 5 piranhas for each person. But then you put in an extra person, each piranha. Each person's only got, between 3, not quite 4 piranhas. So the ratio changed. The ratio did change when you added 1 to each. That's not good enough. What you need to do would be to multiply. If you multiply both by 2, like 4 people, 20 piranhas, then still be the same. 5 piranhas per person. And question 3, showing some simplifying there. First one divided by 2, second one divided by 8. You could do it in multiple steps, but the final answer needs to be 3 to 1. Make sure there should be 2 dots there. I don't know why it looks like 1. There we go. Third one. Now, third one, I understand people are going to start wanting to use calculator. So I'll make it a bit bigger here. Oh, and I'll scroll down a bit so you can see the answer. 5 to 1. So how to simplify fractions using a calculator. If I did use the fraction. So what your calculator is doing is simplifying a fraction. And the way you simplify a fraction is almost exactly the same as simplifying ratio. So we're just going to use that fraction simplifying function to help us out. 10 to 8 became 5 to 4. 24 over 8 became 3. So if that happens, you need to write that as 3 to 1. 0.45 over 0.09 5, so you have to write it as 5 to 1. But the last one, 6 to 12 to 15, you can't, like, if I do 6 over 12, like 1 to 2, and then I do 12 to 15, 4 to 5, it doesn't quite match up. What you need to do is, for now, you got to do this by hand. So divided by 3, 6 divided by 3 is 2, 12 divided by 3 is 4, 15 divided by 3 is 5. I don't see a way to do it with a calculator. Now that review stuff on the right, really good review stuff. It's better explanation what I gave in previous lessons. So just real quick, a ratio is a comparison of two amounts. It's a comparison. And you've got an example there, drinkers and non-drinkers. Simplifying ratios. Some ratios are equivalent to each other. 6 drinkers for each non-drinker is the same as 3 drinkers for each one. 6 to 2 is the same as 3 to 1. If you're in the room, those ratios, it means the same thing. And we prefer to write them as simply as possible. That means we want whole numbers, no common factors. So if I had like 20 to 10, I'd prefer to write that as 2 to 1. 10 goes into both of them. And then I just gave an example there. All right, hey, questions 4 and 5. So I'm going to scroll down. 3, 2, 1. Questions 4 and 5. These are the things we did in the last 2 lessons. Just trying to scroll up a bit, but it won't let me. Oh, there it is. Got it. So we got 2 questions here. One, we're splitting a wheel up in 3 parts. Oh, move some stuff out of the way so you can actually see the explanation. And how do you do it? Explanation is on the right. And number 5, another question there. This time they give you the number of students. You've got to tell me how many teachers there are. Explanations on the right. So I'm going to pause, and then the answers will be there. And here are your answers. So the way we do question 4 is we say, okay, so the ratio is 4 to 3 to 2. So if I add those up, 4 plus 3 plus 2, that's 9. What that means, if I were to split that 180,000 into 9 equal parts, first person would get 4 parts, next person would get 3, last person would get 2 parts. So it's a nice way to do things. If we divide it into 9, all the numbers will work out really nicely. So we say 180,000 divided by 9, 20,000. Each part is 20,000. So the first person gets 4 lots of 20,000, then 3 lots of 20,000, 2 lots of 20,000. And you get your final answers. 80, 60, 40 grand each. Might as well circle that, make it clear. Those are your answers. So that's what we're doing there. For the other one, what we're looking there, we say, okay, so there's 900 students. Let's say there are 45 equal parts that make up that 900. If I do 900 divided by 45, each part would be 20, and therefore the number of teachers would be 2 times 20. So basically, 900 students, the students was the 45. So you say, hey, let's make that 45 equal parts. And you find out the value of each part, which is 20. So therefore, teachers is going to be 2 lots of that. Basically, just follow the process. If you have any questions, you can go back, previous pages, practice, practice, practice. 4 teachers. Explanations on the right. I'm going to scroll down when you're ready. Oh, not scrolling down, actually going to the next one. So here's the new stuff. Scale drawings. Scale drawings are a special application of ratios used to create a real object, which is too big or small to draw. So if you're making a football field, and they say, okay, can you draw us, a picture of the football field? Show us what it'll look like when it's finished. If you draw it at full size, that's going to be a really big picture. So instead, we shrink it down using ratios. Same thing with a bacteria. They say, oh, show me a drawing of a bacteria, but make it the right size. It's like, oh, too small. You can't draw that small. No, we're going to use scale to make it big enough so that we can see it. So we use ratios there. This is all about ratios when we're doing maps and scale drawings. All right. So what we said, lengths and distances on the scale drawing are in the same ratio as the real lengths and distances. So it's the same ratio of the original and of our drawing. Scaled length and the actual length. Scale drawings are used when building a house, definitely. Ratio of 1 to 100. So this is where it gets point. Ratio of 1 to 100 means one measurement on the diagram is 100 for the actual. So actual. So the first number is our diagram, our drawing, and the next number is our actual. So for this scale, it means the actual thing is 100 times bigger. So for example, if I had something 6 centimeters long on the drawing, that means it's actually 600 centimeters across. So 6 meters. All right, that's what we're doing. We'll mostly look at the diagrams like that, where the actual objects are bigger than the picture, but you got to be the other way around. So 5 to 1 means the drawing, 5 centimeters on the drawing, would only need 1 centimeter of actual. So that's something we've made 5 times bigger. I don't know, something like an ant, and you want to draw it just 5 times bigger? I don't know. Grasshopper. So grasshopper is a little bit too small. So let's just make it 5 times bigger, and then you can see all the different parts. And there you go. What objects do we think? Okay, so example 1. This is stuff you're going to have to write down here. Example 1, it's a scale bedroom design. If the scale is 1 to 50, find how many times larger the actual bedroom dimensions are with the diagram. So the first number is our drawing. So write it again, 1 to 50, drawing, and then we have the actual. So how many times bigger? 50 times bigger. 50 times larger. That's what that 1 to 50 means. If you look up stuff on Google Maps or other websites, down the bottom, you'll have the scale. It lets you know what scale is being used. So what, and you can measure on the screen compared to real life. Okay, scaled length of the bedroom in centimeters. So the length of the bedroom, I'm going to say, is down here. The scaled length. So they just want you to know, they want you to say, how long is that? Now this you're going to need a ruler for. So I need you to pull out a ruler, and you need to measure that. How many centimeters is that one there? Put that one. You need to measure that one. Well, I can do better than that. So that one goes there. Okay, next, you're going to, the actual length of the bedroom, we need to take that measurement you got already and times it by 50, and that is the actual length. So you're going to need to do that. Then lastly, what you're going to need to do is, it says the actual length of the bedroom in meters. So take that actual length you got in centimeters and convert that into meters. Again, using a calculator. So you're going to need to do this one. I can't just copy off me this time. You're going to need a ruler. All right, so I'm going to pause. Before I pause, get myself back to full size. That's big enough. But this calculator needs to be bigger. There we go. All right, I'm going to pause now. Have a go at that using a ruler. 3. All right, now I don't have answers for you this time because there's something you got to do. But I'm going to scroll down now on to the next bit. All right, just a quick check. We've got that page and we've got a few pages of questions to do. Don't know if we'll get through them all. Example 2, find the actual length of the screw. So you need to measure it, the length, the drawing length, measure that. And now this means that 5 to 1, the actual one is much smaller than the drawing. So the drawing is 5 times bigger. So what that means is you're going to have to get the length you measured and not times it by 5, but take it and divide it by 5 and figure out what that is. All right. Now, questions. We've got this first page here. 1, 2, and 3. We can just fit that on. I'm going to do those 3. And just keep on going through these questions, I'll give you the answers for the first three, then the next ones, and the next ones. So pause here, and when you're ready, I'll unpause, and you'll have the answers. Now, I don't have answers for the first one because you need a ruler for that one. So you measure it, and then take that measurement and multiply it by 100, because that 100 is the actual length. It's 100 times bigger than the drawing. That'll give you the answers in centimeters. And for meters, you're going to have to divide by 100. So if you had 350 centimeters, divide by 100, you get 3.5. So that's in the calculator here. That's if an example was 3.5 centimeters times by 100, 350 centimeters. To convert to meters, you divide 3.5. So when this scale 1 to 100, it turns out that each centimeter represents a meter. But that's just a fluke. I've got the answers here for the other ones. For question 2, just multiplying by 100, dividing by 100, same thing. Okay, but then question 3, we get on to different ratios. So this is 1 to 1,000, 45 times 1,000, 45,000. Turned out to be 45 meters. So 1 to 1,000 means that each millimeter represents 1 meter. So it's a useful scale as well. I'm going to scroll down. 1. All right. So now we've got some measure the length of the scaled image, and then use the scale ratio to work out the actual length. So the big things to look for, this is from 1 to 3, the actual 3 times bigger. Here, the house, it's 100 times bigger. And so on and with the other ones. The actual 4 times bigger, 20 times bigger. So on the last one, oh no, that's for B. For these ones, so measure it, multiply. I won't give you answers for those. Question 5. Good. Have a go at that. Question 6. Now these ones here, look, we've been given the drawing. In order to work out the actual length, you're going to need to divide by 100 to get from the original, from the drawing back to the original, from the drawing to the actual. This one here, you're going to have to divide by 3. Now this one's tricky, 4/3. That one's a tricky one. Back theorem's easy, just divide by 100. So this one, bit of a challenge, is do it the method we've done so far. If the 4 is the drawing and 3 is the actual, go 4 parts is equal to whatever you measure. So 1 part is equal to 3 parts is the actual. So divide by 4 times by 3. Tricky. That's question 6. And then last one, question 7. Good. One more. All right. I'm going to pause and give you answers for 5, 6, and 7. All right. Here's the answers for question 5. So question 5, I had to multiply by 80 here. 1 centimeter in the drawing represented 80 centimeters in the real world. So we multiply by 80, we get 48 meters, 32 meters. To find the area, times the length times the width. I'm going to scroll down. I couldn't give you the answers to question 6. Wait, because we needed to measure. And question 7, this was the one divided by 100. So 80 divided by 100 is 0.8. Show you that in calculator. So that's 0.8 centimeters. And how do you get from centimeters to millimeters? Times by 10. All right, going to stop there. That's our lesson. Covered a lot there. Going to do a bit more stuff on the scale next lesson. Maybe a little bit harder. Yeah.